Hello everyone, welcome back to ECE111 classes. So today we are going to learn about dependent sources. So till now whatever we know about sources are that sources are of two types. So first one will be current source and second one will be voltage source. Okay, and whatever we know till now are independent sources. So this is independent current source and this is an independent voltage source. So this is what we know till now. Now today we are going to learn about dependent sources. This is a new topic. So let us see what are dependent sources. So as like independent sources, here also we have current source and voltage source, and these are the symbols that you can see here. These are your symbols for dependent sources. So here we have, this is your current source and this is your voltage source. Now why we are drawing four sources, or why we are repeating two current sources and two voltage sources? So let us see. So these dependent sources are dependent on certain other voltage or currents. So for example, like if we have a current source which is dependent on a current source, then we call it as, suppose it is dependent on a current which value is suppose IA, okay, and alpha is suppose a constant value. So it will be called as your current dependent current source. Okay, then if it is dependent on a voltage, suppose it is dependent on a voltage VA, then it will be called as voltage dependent current source. Okay, so similarly if we are considering voltage sources, so if it is dependent on some current, so suppose gamma is the constant, suppose it is dependent on current IB, then it will be called as current dependent voltage source. Okay, and if it is dependent on some voltage, suppose, so let us consider delta and voltage is suppose VB, then it will be called as voltage dependent voltage source. Okay, so we have four types of dependent sources: current dependent current source, voltage dependent current source, current dependent voltage source, and voltage dependent voltage source. So as we know about the sources, it is of only two types, current source and voltage source, and then depending on whether it is dependent on current or voltage, it is called as current dependent or voltage dependent. Okay, so now let's see, if these sources are present in circuit, then how we are going to write down the KVL equations, or how we are going to solve the circuit. So this is one example, one such example is shown here. So as you can see here, our circuit is, everything is normal, what we see or what we observe till now. So now what is the difference, basic difference between previous circuits, whatever we have solved earlier, and this circuit is, here we are having a dependent source. So this is one dependent source. So as you can see, this is a voltage source, right, and it is dependent on a current. So this is your current dependent voltage source. Similarly, this is also a voltage source and it is dependent on current. Okay, so current dependent voltage source. So both are current dependent voltage sources, and remaining whatever elements we have, those are our normal circuit elements. Okay, so if we want to write down the equation for this circuit, then first of all, as we have already discussed in the last class, how to write KVL equations. So in that direction, first we have to write down the loop current. So let us consider this is our first loop, so I1, and this is our second loop, so I2. Okay, or we can also say that for mesh 1 I1, and for mesh 2 it is I2. So now if we are going to write the equation for suppose mesh 1, okay, so you continue this, so writing KVL for mesh 1. So let us start from this point. So from this point if you write it, then it will be, first we are encountering 5 volts, so it will be plus 5 volts since it is going from negative to positive, then minus of 5 I1, Then if we consider this as a voltage source only, then the sign will be going from positive to negative, so it will be minus, and the value is your 10 IB, right? So we write it like this. Then coming back to your circuit, now we have minus 10, and as we already know, this will be I1 minus I2. Then again we have another voltage source, so it will be now again minus negative to positive to negative, so it will be minus, and the value is 5IA equals to 0. Okay, now let us write down KVL for mesh 2. So let us start from this point, moving in clockwise direction. So we are having minus 5 of I2, then this will be minus 10, then it will be plus of 5IA, and again we have minus of 10. Now it will be I2 minus I1, right? So we have written the equations as per our knowledge. Now but two steps solving your dependent sources. So now if we see what is our IA and IB, IA is nothing but I1 and IB is nothing but I2, right? Because I in this direction whatever current we are having, that is nothing but I1, right? And in this direction whatever we are having, that is nothing but I2. So IA equals to I1, IB equals to I2. So if we put this here, in place of IB it will be 10 times of I2, and in place of IA it will be 5 times of I1. Okay, now in our equation what we have two variables. Yes, this will also be minus of 5, IA is I1. Okay, so in our equation we have I1, I2, right? In this equation also we are having I1, I2. So finally what we are having is I2 variables. So we have two unknowns and two equations. So if we solve them, then if I consider this as number 1 and this is my number 2 equations, so if I solve them, then this one we will be having as my 5 minus of 5I1, then it is minus of 10I2, then minus of 10I1, then plus 10I2, then minus of 5I1 equals to 0. So what we have here is I2 gets cancelled, and finally what remains is minus of 10, 15, 20. So it will be 20I1 equals to minus of 5. So finally what is the value of I1 is 5 divided by 20, so it is 1 by 4. So we can call it this is as 0.25 ampere. Okay, now similarly if we solve the second equation, then we will be having so second equation, as you can see here, so it will be minus this is your minus 5 of I2, then 10 minus 5 of so this is plus 5 of I1, then minus of 10. So finally if we solve, I am just skipping the steps, so it will be getting I2 as I2 equals to minus of 0.416 ampere. Okay, so we have the values of our current, right? So we have two equation, two unknown. After solving we are getting these two values. So as you can see the value of I2 is negative. That means whatever direction we have considered, that will be in the opposite direction, and then we can say I2 as 0.416 ampere. Okay, or we can keep it as it is, and the direction will be in the clockwise direction only. Okay, so I guess you have understood this numerical. So similarly we can solve another numerical. So let us consider now this numerical where we are having dependent sources, two dependent sources, and these two dependent sources are voltage dependent voltage sources, right? Both are voltage dependent voltage sources. and first voltage source is voltage dependent voltage source, and it is dependent on voltage V2, and V2 is the voltage drop across this 2 ohm resistor. Okay, and next this voltage source is dependent on 2V1. 2V1 means the V1 is nothing but voltage drop across this 5 ohm resistor. Okay, so similarly last numerical we'll be writing down the equations. So beforehand, if you want to write down what is V1 and what is V2, that we can definitely write. So suppose V1 is nothing but the voltage drop across this resistance, so which is nothing but 5 of I1. Why I1? Because this is your I1 and this is your I2, right? So V1 is minus of 5 I1. Similarly, if you write about V2, so what is your V2? V2 is nothing but minus of 2 I2, the voltage drop across this resistance, right? So this is, okay, let me see, this is I2, this is negative to positive, this is positive to negative. Yes, this will be okay, let's see about the direction later. So first let's write down the KVL equation. So KVL equation for loop 1, so it will be minus of 5 because we are going from higher potential to lower potential, then minus of 5y1 voltage across 5 ohm, then minus of 2v2, then minus of 4i1, then minus of 1 into I1 minus I2, and then again we have plus of 2v1 equals to 0, right? Then similarly we have, if we start from this point, so it will be minus of 2i2, then this will be minus of 10, then we are having again minus of 2v1, then minus of 1 into I2 minus I1 equals to 0, right? So now if we are putting the values, then in place of V1 and V2, so here in place of V2 and V1 we will be putting out the values. So across your V2 it will be 2 times of I2. So let us see first the direction. So as you can see here, as per our normal directions says this should be plus minus, right? So but the direction of your V1 is given opposite. Okay, so that is why the value of the voltage drop across this should be actually minus of 5i1 in the clockwise direction, but is in the reverse direction, so that is why it will be plus 5i1. So accordingly, as per our directions, so this should have been plus 5i1, but due to this negative polarity, so it will be considered as minus of 5i1. Okay, now similarly in this case, as you can see, our direction, that is clockwise direction, in and whatever direction should be for this 2 ohm resistor is also same, that is plus minus, so it should be plus of 2i2. Okay, so now if we put these values here, so then in place of this V2 we will be putting as 2 times of I2, right? And in place of V1 we will be putting as minus of 5 times of I1. Okay, now if we reduce, or if you write down the formula again after minimizing, then we will be having it as 20 times of I1 plus 3 times of I2 equals to minus 5, and then for the second equation we will be having 11 times of I1 minus 3 times of I2 equals to 10. Now after solving this, we'll be having the value of I1 and I2, and it will be coming as 0.161 ampere, and I2 will be coming as minus of 2.742 ampere. Okay, so I'm not going into the detail of solving this, solving the numerical. I guess you can solve those things. So the main idea behind this dependent sources is, so what we have to do is we have to consider, whenever we are writing the equation, then we have to consider the sources as it is. That means like normal sources, how we treat them, but the value will be whatever is given across the sources. For example, suppose if we are considering this source, then we will be considering this as a voltage source. So if we are considering this as a voltage source, then it will be obviously from positive to negative it is moving, so value will be negative, right? And whatever you will be writing in place of value, so it will be 2 times of V2, so we will be writing it as 2 times of V2. Okay, then similarly if we are coming here, so for suppose this loop, so it will be minus to plus, so it will be plus, and the value will be 2 times of V1. So this V2 and V1 we can write from the value of wherever it exists, for example here and here, right? So in this case, whatever be the voltage drop, in this case, in the first case, as you can see, the direction of our current and the direction of the voltage drop is opposite, so it is why we are putting it as negative. And in case of the second one, you can see both the direction of your source and the direction of your loop are in the same direction, so we can consider it as positive. Okay, so now just substituting those two values, we can solve the numerical. Okay, so this is how we can solve dependent sources or the numericals which contain dependent sources. So it is nothing to be afraid of, or nothing to be think like that it will become tough if we are having a dependent source. No. So what you can do is we have to just consider them as normal independent sources, and then just put the values whatever is assigned, and those values will again replace by their dependency. Okay, so this is all about your dependent sources. So next we will be discussing about dependent sources and independent sources with some other logic which is called as super mesh. So till then, thank you, and meet you in the next class. Thank you again.